Good morning, everyone. Like you heard, I'm Nir, the founder of Palo Alto Networks. Just one word about Palo Alto Networks. Palo Alto Networks is by far the largest cybersecurity vendor in the world, with a market cap approaching $60 billion and probably more than 3 times larger than the largest cybersecurity vendor in Israel. It's an American-Israeli company. That's it about Palo Alto Networks. Now let's talk about the industry a little bit. So I often get asked by customers, why do they have the feeling, and why do we all have the feeling that the cyber attackers, the adversaries, are winning? It's just like, it doesn't matter what we do. It seems like things get worse and worse, and that it gets easier and easier for the adversaries to attack and shut down gas pipelines and hospitals and insurance companies and banks and so on. And there are different excuses for that. I don't think that many of them are true. Like, for example, the adversaries are very innovative. Have you seen how much money is going into the defense side? Just all the investment in cybersecurity in Israel and elsewhere. We are also very innovative. The attackers are very determined. Well, we're also very determined. The attackers have a lot of money. If you look at the defender side, most of our customers, most enterprises that we see, spend between 4 and 6% of their IT budget, including people, applications, servers, clouds, and so on cybersecurity, 4 to 6%. In Israel, unfortunately, it's a little bit lower. You should increase that. Critical infrastructure, banks, and so on, we're seeing 10% of IT being spent on security. So yeah, the adversaries are getting better and better funded, but so is the defense side. There is this excuse that it's easier to be an attacker than a defender, because the attacker has to be correct once, meaning we, as a defender, have to be correct 100% of the time. They'll try again and again and again and again, and they only need to succeed once to be inside. That's true. However, we are seeing more and more spend in cybersecurity, that's relatively new, going into the other side of things, meaning assuming that the attacker has already breached the perimeter, they're already inside, and now we need to detect them when they are inside. That turns the table to now we have to be correct only once, we have to find them, and they have to be under the radar 100% of the time. So all these excuses just don't make any sense. There has to be another reason why things don't go forward, and many go backwards in terms of our ability to stop cyber attacks. And it has nothing to do with the innovation and the money and all the other things that we keep attributing to the attackers. It has to be something else. So if we look at the way cybersecurity is being procured and deployed and so on, it starts with the architecture. It starts with the architecture group inside the information security group that needs to architect cybersecurity solutions. And traditionally, they worked on one project at a time, and there wasn't really any architecture. Things are getting better. We're seeing more and more organizations creating a cybersecurity architecture that is cohesive from end to end, so that things are more, different parts of cybersecurity work together, and they talk to each other, and they learn from each other, and so on. We're seeing more and more move towards platforms, and that helps. So I think that on the engineering side, we've made a lot of progress, and that's not the reason why today our adversaries are having relatively good success. After you engineer the solution, you have to buy it. Like I said, there is more money going into cybersecurity, 4 to 6% of IT budget, sometimes 10%. That's usually enough money to go and buy the solutions. Deploying the solutions has traditionally been difficult, meaning if you buy it, you need to deploy it, it takes time, and it's complicated. The industry has made it simpler. You're seeing more and more cybersecurity solutions being delivered as SaaS, software as a service, where you don't have to deploy anything. We're even at the point where you can deploy network security inline without deploying anything. You know, there's network security delivered from the cloud. All you have to do is to deploy maybe an agent on endpoints and SD-WAN, unmanaged SD-WAN device in a branch. So even the deployment side is becoming easier and easier. Now, so you architected a solution, you engineered it, you bought it, you deployed it, and all of that over the last several years, the industry has made easier and easier and easier to do, and now organizations can design and buy and implement cybersecurity solutions very, very quickly, much quicker than it was 5 years ago. So now we are to the last frontier, I think, in terms of why we are behind our adversaries. And that has to do with operating the cybersecurity infrastructure. So once you deploy the solution and it's in there, you have to operate it. And a lot of that operation is done very manually today. So yeah, you have to configure it and so on. That's a little bit more automated. But then at the end of the day, a lot of the cybersecurity infrastructure is about finding issues in the infrastructure, in the network, on endpoints, in applications, and so on, and delivering the events, alerts, incidents, and so on to one central location which is called the Security Operations Center, the SOC. So everything comes to the SOC, and now the SOC has to deal with that. Now, in many cases, the infrastructure has already blocked the attack, right? Someone tried to do something, the network security, the endpoint security, whatever it was, found the attack and stopped it. Do you need to investigate that? Sometimes yes, sometimes not, but that's okay. But more and more of what's happening in the infrastructure cannot be stopped locally, meaning there's not enough information locally where the network security is deployed, or endpoint, or cloud security, application security, and so on, and the decision has to be made centrally. And that's, again, the role of the Security Operations Center. Now, the Security Operations Center hasn't grown very much in the last, 25 years that I've been in the industry. We're still seeing most organizations having a handful of people in the SOC, maybe 10 in a shift. The very large organizations that we serve have, maybe 50 SOC analysts during a shift in the SOC, while the infrastructure has grown much, much more than that. If you look at the infrastructure 20 years ago, and 10 years ago, and 5 years ago versus today, we moved from a few data centers with physical servers to many, well, now it's cloud data centers, but with a lot of workloads, VMs and containers and serverless functions. We moved from a world with a few monolithic applications to many more applications. Some of them are on-premise, some of them in SaaS, some of them public cloud. Many of them have microservices architectures, so they're broken down into very, very small pieces. Each needs to be managed and secured separately. Of course, the amount of users in our infrastructure has grown significantly. All of that generates more and more and more and more work for the SOC. More events, more incidents, more alerts, things that need to be investigated. And the SOC hasn't grown the same way, the exponential way that the infrastructure has grown. So we're expecting the SOC to do things in an infrastructure that is 100, 1,000 times bigger than it used to be with about the same number of people. And of course, that's not going to work. And we often see that's being the bottleneck in cybersecurity. Now, you want the proof? Here's the proof. In almost all the data breaches that have happened, those that we looked at, those that we haven't looked at, others investigated and published the results, almost 100% of the time, eventually, the organization came back, usually information security, usually the SOC, and said, here's what happened. We have all the information in our logs, in our data, wherever that is, to show what happened. We know that the adversaries came from here, and then they jumped here, and then they did this here, and jumped here. They had all the information. So if you have all the information after the breach, after the gas pipeline got shut down and the hospital got wiped out, if you had all the information, why didn't you do anything about it? Like, if you had all of it, why didn't you just stop the attack? Why did you wait until the attack was successful and then show that you knew about it, or you should have known about it? That's because we have all the information to know that we're being attacked. We just can't get to it because we're using people to do that. And that has to change. So over the last few years, we have seen more and more automation technology for the SOC coming out. Probably heard about SOAR, S-O-A-R, Security Orchestration, Automation, and Response, which is really a cool name that cybersecurity people invented for something that's 25 years old that's called RPA, Robotic Process Automation. For those of you who remember what that is, it helps. It automates some things. Then there is a little bit of machine learning here and there that automates a few other things. But it's been done a little bit, or actually not a little bit, very much like the car industry has been trying to create automated cars by adding features here, features there, right? We started with a car, and then we added adaptive cruise control, and we added lane keep assist, and we added automatic braking and automatic parking, and over time, adding more and more automation features is not going to create an autonomous car. The same thing in the SOC. Adding more and more automation features helps. It makes the SOC more efficient, but it's not going to get us to an autonomous SOC. Now, why do we need to get an autonomous SOC? Again, because we have all the information to know that we're being attacked. We have everything that tells us that we're being attacked, and humans just can't deal with that amount of information. We need the SOC to work by itself, okay? We need to completely change the role of the humans in security operations from those that run the security operations to those that help the machine, and we need a different approach for that. I'll give you another interesting thing before I talk about the autonomous SOC a little bit. Most security operations centers in the world, and I'm talking about close to 100%, don't investigate all the incidents that they have. Like our SOC at Palo Alto Networks, we are a decently sized company, about 12,000 employees in many countries around the world. We are very close to being a Fortune 500 company. So a decent sized company, we get several hundred thousand alerts in the SOC every week. It's like, we'll need probably 10,000 people to investigate all of them, so we don't. And what most organizations do is they write rules to decide which of these alerts, which of these incidents can be ignored. Well, if you saw a connection going to port 81 and you blocked it, why would you investigate it? Let's ignore it. Well, maybe it's part of something bigger. You need to investigate it. But they don't. And like I said, every time something happens, they come back and say, oh, actually, we had the data. It's just that our rules ignored it because we only have the ability, the capacity to handle 50 alerts in the SOC per week, and we're getting hundreds of thousands. So that's another reason why we need the autonomous SOC. We need to switch to a mode in the Security Operations Center from reducing the number of alerts magically to the same number of alerts that we can handle every day or every week to, no, we need to handle all the alerts. There's no such thing, you generate an alert and you don't handle it. Why would you do that? All of you do that today, by the way. All the companies that you work for, okay, maybe a few not, but almost all of you do that. So we have to change the mode. That's why we need an autonomous SOC. We need to SOC to run automatically, and with the amount of data that's required to do that, that means we need to use a lot of machine learning, a lot of AI, move the people aside, have the people help the SOC, and we believe that's the new frontier in cybersecurity. A security operations center that runs the entire cybersecurity infrastructure, regardless of the vendors that are deployed in it, completely in an automated way. And the way to do that is very similar to the way the car industry is building the autonomous car. Rather than taking a car and adding automation features over time, which is not going to get us anywhere, of course, you need to start and say, I want to build a car without a driver. I want to build a car without a steering wheel. And how do I do that? And you do it. And that's what some of the autonomous car vendors have done, or in the process of doing. They're getting closer and closer to that. You build a car, assuming there is no driver, assuming there is no steering wheel, and then if needed, you add some human features to help the car when needed. We believe the same approach is required in the SOC. We believe that's the new frontier in cybersecurity. And that's the last piece we believe that's missing in our ability to deal in time, detect in time, respond in time to cyber attacks that are happening nowadays. And once we do that, I believe that this question of why do we keep losing to the adversaries? Why do they keep attacking us and are being successful at it? That question is probably going to be heard much, much less than I'm hearing it today from customers. Okay? That's it. Thank you very much. Enjoy the rest of the show.